Welcome back to my channel. Today we are going to be discussing about the top k elements pattern. This is another pretty popular pattern in relation to algorithm and data structures, and it's also a really popular pattern that we need to know. Okay, so let's jump into it. This is the top k elements pattern. So now the idea of this pattern is usually to return the top k elements in a list. So when you see questions that say things like return the top k elements, so maybe the top k could be any number, so maybe the top 5 elements, top 10 elements, the top 3 largest elements, the top 3 smallest elements in a list. That is the top k element pattern. That should just immediately point you to the top k elements pattern. So how do you solve this problem? Let's just give an example that we can walk through. Say that you are given an array of some elements. So that you have the element 2, you have the element 3, you have 9, then you have the element number 4, you have 1, you have 8, 12, and 6. And then you get the question so this is your array, and then the question says you should return the top 3 largest elements. This immediately suggests to you that you have to use the top k elements pattern to solve this problem. Now, ideally, looking at this question, if you are asked to return the top 3 largest elements within this array, what you simply need to do is go through the entire array to find which of the elements is largest, then pick the elements that you expect to, then pick the next largest and then the next largest. Yeah, so roughly a reasonable way to do it is to probably sort out the entire array. Once you sort it in a particular order, let's say ascending, you can now get like the top 3 at the very end of the array. However, sometimes you are not allowed to sort. At some other times, you don't have enough space to sort. And in some other cases, you would have an input element that is a stream. So a stream is like a constant flow of elements, constant flow of data. And so these are usually the constraints that you have that will then force you to think about a much more efficient way regarding time and space complexity to use the top k elements pattern. So now let's just quickly discuss how this pattern works. The idea of this pattern is that we will have this list of elements, and then to return back the top 3 elements in the pattern, we need to use a very special data structure called the priority queue. Now, this data structure is optimized for removal of the largest or smallest elements in a list. So actually, it does this in a O of log n time, which is pretty efficient. So removal from the list and adding back into the list is done in O of log n time. And being able to determine the smallest or largest n element in that list is also being able to determine the smallest or largest element in that list is actually a constant time operation, and being able to remove that element is a logarithmic time operation. So it's pretty fast. Now, to solve this kind of problem, so knowing that we have this kind of data structure such that the largest or smallest elements within the list can be returned back this in this time complexity, it does suggest to you that we could have like different variations of this priority queue. And actually we have a max priority queue. So I'll call the priority queue the PQ. And we could have a min priority queue. So with the max priority queue, the largest elements within that list will be at the very top of the priority queue. And that element can be removed in logarithmic time. At the same time, we can find out what element that is in a constant time. While the smallest element, for a mean priority queue, the smallest element is at the very top. So now, how do we now solve this particular example that we have using the top key elements pattern? So let's have a copy of this and quickly make use of it for this problem. All right, so to attempt to solve this problem using the priority queue, what we just do is, since we want the top 3 largest elements within this entire array, what we can do is we would create a data structure that sort of puts, like a priority queue that puts, or rather a priority queue that, this is the word, evicts the smallest element. Yeah, so once we create a priority queue that evicts the smallest element, that basically means we want a priority queue that allows us to quickly access the smallest element within a priority queue, and that suggests that we are going to create a main priority queue. So now once we create a main priority queue, we know that we will have the smallest element in the priority queue at the very top. So now with that, all we just have to do is create insert a priority queue of a size of 3. So if you insert a priority queue of a size of 3, since we are requested to return the 3 largest elements within the entire array, so create a priority queue of a size of 3. Then for every element, we would try to ensure that the priority queue, the size, we ensure that the size never exceeds 3. So to do that, all we simply have to do now is to add elements into the priority queue. So initially priority queue is empty, so immediately we had 2. Then we move from 2 to 3, we check priority queue is still empty, we add 3. Then we move from 3 to 9, we realize that priority queue is still empty, then we had 9. Yeah, at this point 2 is at the top of the priority queue because 2 is the smallest of all these elements right now in the priority queue. So it's going to be at the top, 2 will be here. Then we move on over to 4. Now before we add 4 to the priority queue, we'll check, is this 4 larger than the element at the top of the priority queue? And yes, it is. So we pop out the element at the top of the priority queue, we remove this, and then we add 4. So the cool thing about the priority queue is that once we remove 2 and add 4 into the priority queue, what happens is the priority queue automatically reorders itself, and then 3 now becomes the element at the very top of the priority queue. So this element now becomes 3. Then we continue to repeat the process. We repeat this process for the next element, which is 1. Is 1 lesser than the element at the top of the priority queue? No, it's not. So we can just immediately discard. We do not process 1, we discard it. Then move on to the next element. Is 8 within this priority queue? Is 8 greater than the element at the top of the priority queue? Yes, it is. So we need to pop out the element at the top of the priority queue, then add it. So automatically, once we do that, remember this priority queue has the ability to reorder itself. So once we do that, 4 now becomes the element at the top. Yeah. Then move on to the next number, 12. Is 12 greater than the element at the top of the priority queue? Yes, it is. So we pop out this 4, and then we insert 12. Now, the moment we insert 12 into this priority queue, so that's 12, 4 pops out, 12 is added. Then we go on to the next element, 6. We realize that 6 is less than the element at the top, so we do not do anything about 6, we just dispose it. At the end of this, we'll have a priority queue. Once we are done going through the entire array, we'll have a priority queue of size 3, and then the elements within that priority queue will be the top 3 elements. Top 3 keys with these elements. As you can see, every operation that we perform here is going to be a log k operation, where k is the size of the priority queue we're trying to achieve, and then we perform that log k operation for all the elements of size n. Every single element within this entire list, roughly we will need a log k operation. For some, we will not perform an operation, but in the majority of the worst case, we will have an O of n log k operation to find this element at the very top of the priority queue. So this is how we solve this problem. This is the pattern for solving this kind of problem, and I would endeavor you to review the top k elements pattern, whereby we have questions like finding the top elements, finding the top k largest, top k smallest elements, top, and then questions that relate to top keys, different variations of those kind of problems. So thank you guys for joining me again for another discussion session on these common patterns. I hope to see you guys again in the next session, where we discuss some other patterns on this list. Please like, share, and subscribe, and see you guys another time. Thank you.